And finally, we'll dive into solving equations. We'll use the techniques that we explored when we were just looking at expressions and apply these now to equations. So we actually accomplish something here. We get to solve for a variable. Questions originally will look like this. We've got some groupings in the form of brackets or maybe in the form of fractions. We'll move into more complicated rational expressions after this, but we'll develop the tools that we'll need using questions like the ones on this slide. Each of these we'll tackle in exactly the same way. The first step in solving an equation is to undo any groupings. So looking at this first question, let's try that. So I want to use distributive property to multiply -6 by 2 and by -3x. So I get 3 minus 12 plus 18x is equal to x minus 5. Groupings are undone. Our next step is to collect any like terms. So 3 minus 12 is -9, plus 18x is equal to x minus 5. And now I want to make sure that all of my terms that have x's are on the same side, and any terms that don't have x's are on the other side. Don't forget the golden rule of equations. What I do to one side of an equation, I must do to the other. But that's actually quite powerful, as it lets us move terms from one side to the other. So I'm going to move the x on the right-hand side over to the left. Because I've got a positive x on the right-hand side, I'm going to subtract x from both sides. So I'll squeeze in a negative x over here. The notation you use for this isn't nearly as important as writing down the correct solution. So my next line is going to have a -9 plus 17x is equal to, well, x minus x is 0, is equal to -5. And many of you may have moved that -9 from the left-hand side to the right-hand side in that same step. And you're welcome to skip many of these steps here. How do we move the -9? Well, because it's negative, I'm going to add 9 to both sides. Maybe I'll squeeze that in here. -9 plus 9, and I then have -5 plus 9. Again, as long as you're doing the same thing to both sides, you can add, subtract, multiply, or divide. In fact, we'll see that we have even more options, as we can take the square root of both sides, or the cubed root, or raise both sides to the same power. But we're not dealing with powers just yet here. All right, so my next line, -9 plus 9 is 0. So I have 17x is equal to -5 plus 9, therefore 4. So to recap, what we first did was open up any groupings, open up any brackets, and groupings could also be fractions, so we'll remove fractions in our first steps as well. Then I moved terms around so that like terms were on the same side, so all the terms with x's on one side, all the terms without x's on the other. And then as a final step, I need to remove the coefficient of 17 from x. 17 is being multiplied by x, so to remove it, I'm going to divide both sides by 17. This works because 17 divided by 17 is 1. So I'm left with x on the left-hand side and 4 over 17 on the right-hand side. A note about this is the final answer because 4 over 17 can't be reduced further, but do make sure that you reduce any fractions to their lowest form. And further, feel free to leave these fractions as improper fractions if necessary. We tend not to write these as mixed fractions. So for example, if the answer had been 17 over 4, we'd be perfectly happy leaving it in that form. Okay, let's tackle the second one. As we go along, I will start to skip some steps, but feel free to use as many or as few steps as you'd like. Here we've got two things going on, two types of groupings. I've got some brackets in the numerator, and I've got a fraction. The entire left-hand side is divided by 3. We can get rid of those in one step. How do I get rid of the 3 in the denominator? Well, because the left-hand side is being divided by 3, you'd use the opposite action, and I'm going to multiply by 3. Of course, what I do to one side, I need to do to the other, so I'm going to multiply both sides by 3. Works nicely. This 3 divided by 3 is 1. So what's left over here is I've got 4x minus 2 times x, so minus 2x, and then minus 2 times negative 4. Negative 2 times negative 4 is positive 8. And on the right-hand side, I have 8 times 3 is 24. Collecting like terms on the left-hand side gives me 4x minus 2x is 2x. And I think in the same step, I'm going to move the 8 over to the right-hand side. How do I move it? Well, because it's positive 8 on the left, I'm going to subtract 8 from both sides. That leaves me with 2x is equal to 24 minus 8, or 2x is equal to 16. One last step that I need to do is to remove the coefficient of 2 from the x. Because 2 is being multiplied by x, I'm going to remove it by dividing both sides by 2. Works nicely, and I'm left with x is equal to 16 over 2, which is 8. How do you know you're right, by the way? How do you know that x, in fact, is equal to 8? What does that mean? Well, it means that if I substituted in an 8 for the x's in the original equation, the left-hand side would be equal to the right-hand side. So that's how we could check. We're not going to check with these, but I encourage you to do a couple of them. So now we get into slightly more interesting fractions. This is going closer to what we'll look at with rational expressions in a few slides. What I notice is that I do have some groupings here, in that I do, in this third question, have a 5 over 7, 5/7 x. I have a fraction. Let's get rid of that immediately. One thing I could have done is taken this 5/7 x and the 3x, move them to the same side, making sure I have those two terms, those like terms on the same side, and then done the required addition or subtraction. But adding and subtracting fractions is a fair bit of work, and I prefer to get rid of the fractions immediately. And then I only have terms with numerators to deal with. So the goal here is to get rid of the grouping, to get rid of the 7 in the denominator. In the previous question, we got rid of the 3 in the denominator by multiplying both sides by 3. And here we'll get rid of the 7 by multiplying both sides by 7. We do have to be a little bit careful here. Stop. Okay. Start. Here, the 7 is being multiplied by 5/7 x, but also by negative 4. In other words, be careful that you are using distributive property. So it might be best if we write it out. We'll take the 7 and multiply it by 5 over 7x, and also multiply it by the 4. So we'll subtract 7 times 4. And on the right-hand side, we have 3x times 7. Maybe just for uniformity, I'll write it one more time separately. So you can see that every single term in the equation is being multiplied by 7. So another way to think about it when you think of multiplying the left side and the right side is simply to apply that multiplication of 7 by every term. It means exactly the same thing. What it allows me to do is to see very clearly that it's only that 7 that's canceled. 7 divided by 7 is 1, so I'm left with 5 times x, or 5x. I do have to take that 7 and multiply it by the negative 4. 7 times 4 is 28, so I have negative 28. And on the right-hand side, 3x times 7 is 21x. What I like about this technique, and we'll see this for all questions going forward, anything that has fractions, is that even though we have one line, this line here, that is often a little bit more involved, once we're past that, our question is fairly straightforward. We don't have any fractions remaining. All that's left for us to do is to collect some like terms. Well, I notice here that the negative 28 is already by itself. It's the only term without an x. It's on the left-hand side. So why don't we move that 5x over to the right? It's positive 5x, so I'm going to subtract 5x from the left-hand side and from the right-hand side. So I have negative 28 is equal to 21x minus 5x, or 16x. The only thing left for me to do is to divide both sides by 16. So now we've isolated x, and I almost have my final answer. I'm going to write it in the other way around. So I'm just going to have the x and the negative 28 over 16 switch sides. Negative 28 over 16 can absolutely be simplified. What are they both divisible by? Well, they're both divisible by 2. That would give me 14 over 8. So they must both be divisible by 4 because I could divide 14 over 8 by 2 again. And that is the largest number that goes into both. 28 divided by 4 is 7, so we have a negative 7 in the numerator. 16 divided by 4 is 4. So our final answer is x is equal to negative 7 over 4. And again, we'll leave it as an improper fraction, as long as it's in reduced form. Okay? So let's apply exactly that same technique to this final question. Our goal is to eliminate all groupings as our first step, which means we want to eliminate the 8 and the 2. What do I need to multiply by to eliminate the 8 and the 2? If I multiply the left side and the right side by 2, I wouldn't quite get there, because I'd have 2 times 5/8, and then also 2 times 1/2 x equals 4 times 2. So that almost works because these 2's will cancel and I'll be left with an x. But 2 and 8, while they do simplify, would leave you with a 4 in the denominator. So that's not quite going to work. So rather than multiplying both sides by 2, what happens if I multiply both sides by 8? Left side and right side. Or I could simply write this as the entire equation being multiplied by 8. So you'll see that as well. Taking the entire equation, multiplying it by 8 is the same as taking the left side and the right side and multiplying by 8. It's essentially one step more of distributive property that we have to do. And then we end up with 8 times 5/8 plus 8 times 1/2 x is equal to 4 times 8. Let's see what happens here. So remember, we're following order of operations here. I'm doing multiplication before any addition. I'm working within terms. I have 3 terms here. I'm working within terms before I add like terms. That's why I'm canceling first. 8 divided by 8 is 1. 8 divided by 2 is 4. 4 in the numerator. And there are no fractions on the right-hand side. So what do we have left? From the first term, we have a 5. From the second term, I have 4 times 1x, so positive 4x. And on the right-hand side, 4 times 8 is 32. So again, we had one line that was a little bit more involved, but it simplifies our equation dramatically. And we've got 4x. I'm going to subtract 5 from both sides. That leaves me with 27 on the right-hand side. Dividing both sides by 4 gives me 27 over 4. If you're not yet comfortable skipping those steps, feel free to write in as many as you need. And if you'd like to skip more steps, that's fine as well. Do make sure that somebody, including yourself later on, can follow your work. The last question here is, why did we multiply by 8? What's special about 8? I noticed that when we did the multiplication by 8, we were able to get rid of all of the fractions. We could also have multiplied by 16. If there is a 16 here, 16 divided by 8 is 2. A 16 here, 16 divided by 2 is 8. That would have worked just fine. What is 8? If I look at the fractions 5/8 and 1/2, I notice that the lowest common denominator is 8. So previously, we found the lowest common denominator when we were trying to add or subtract fractions, but it's useful here as well. If we take an equation and multiply it by the lowest common denominator, that will allow us to eliminate all of the denominators while keeping our numbers as small as possible. So we're going to explore that idea in more detail with the rational expressions, the rational equations. Okay. So these are the rational equations, or just equations that involve fractions, particularly those where we have a lot of x's, and particularly x's in the denominator. We're always going to apply the same steps we did before, but the first step, the part where we're getting rid of any groupings, is split into the 3 steps written here. First, we'll find the lowest common denominator. And then in order to get rid of the denominators in each term, we're going to multiply each fraction by the lowest common denominator. Or rather, multiply each term, even if it's not a fraction. And then we solve the resulting equation by isolating x. Let's look at the first question. Maybe a refresher on finding the lowest common denominator. A strict way to do it is to write down the prime factors for each denominator. So the prime factors of 4 are 2 and 2. Prime factors 3, well, are just 3. And the prime factors of 6 are 2 and 3. The LCD has to be divisible by 4, by 3, and by 6. So I have to make sure that all of the prime factors are represented. So looking at the first term, in order to be divisible by 4, I need to be able to divide the LCD by 2 2's at the same time. In order to make sure that my LCD is going to be divisible by 3, I need to make sure I have a 3 in it to accommodate the second fraction. To accommodate the last fraction, I need a 2 and a 3. Well, I already have a single 2 and a single 3, so that doesn't change the LCD at all. 2 times 2 times 3, 4 times 3 is 12. Okay, so we'll take the entire expression, the entire equation, and multiply it by 12. Okay, let's draw that out a little bit more carefully. So I'm going to take every single term and multiply it by 12. I'm just using distributive property here. So sometimes I'll draw it out this way and really just give myself a scaffold to work with. There is every single term just spaced apart a little bit. And I've just thrown the negative sign over here so that I can multiply by 12. And then I'll throw in the 12. So taking 12, I'm multiplying it by every single term. Now I can cancel. 12 divided by 4 is 3. So all that I have left from the first term is 3x. 12 divided by 3 is 4. And 12 divided by, I've written 16 here. This should be a 6. So I have 12 divided by 6 is 2. All right, let's see what the next line looks like. So we said we had 3x left from the first term. Here I've got negative 4 times 1, so negative 4. And on the right-hand side, I have x plus 6 times 2. That's much more simple. It looks like the very first problem that we tackled. And in fact, we could have used distributive property right away and not written this extra step. Let's write it in here. So our last grouping to get rid of is the brackets around the x plus 6, and we have 2x plus 12. Collecting like terms, collecting x's on the left-hand side gives me x, subtracting 2x from both sides. And on the right-hand side, well, I need to move the negative 4 over to that right-hand side. So I'm going to add 4 to both sides. There's already a 12 there. So I'm left with 16. Okay, we'll use that step for every single equation, that same process rather, for every single equation that has fractions. So try this next problem. What's the lowest common denominator? The LCD has to be divisible by 12, by 8, and by 6. Well, maybe we could write it out this way. I don't have to go all the way to prime factors. 8 is just 4 and 2, and 6 is 2 and 3. And I can stay at 4 here because I recognize that both 12 and 8 are divisible by 4, or by 2 2's. You can start to bend the rules a little bit. So in order to be divisible by 12, my LCD needs a 3 and a 4. In order to be divisible by 8, it needs a 4 and a 2. Well, I've already got a 4, so we're going to add in an additional 2. And to be divisible by 6, it needs a 2 and a 3, which we've got. Be fair to yell at this point and say, what about the x's? Well, of course, those are part of the LCD as well. So we can add in an x to the list of factors for the first term. Again, a single x to the list of factors for the second term, but there are two x's, or x squared, for the last term. So I'm going to need to make sure I have x's to the highest power in my LCD. So here, our LCD is 3 times 4 is 12, times 2 is 24, is 24x squared. So our job now is to take this entire equation and multiply it by 24x squared. So to save some space, I'll just write it once, 24x squared with brackets around the entire equation. So I'll want to take that 1 over 12x and multiply that by 24x squared. And start. So I'll want to take the 1 over 12x as well as the 1 over 8x as well as x plus 2 over 6x squared and multiply them each by 24x squared. All right. That's really the worst of it, and now we get to simplify. 24 divided by 12 is 2, and x squared divided by x leaves us just with a single x in the numerator. So far, what's left in the numerator? 2 times x times 1, just 2x. 24 divided by 8 is 3, and x squared divided by x is once again just going to leave us with an x in the numerator. So we have positive 3 times x times 1, or positive 3x. And on the right-hand side, 24 divided by 6 is 4. X squared divided by x squared is equal to 1, so we don't have any x's left here. Maybe use distributive property right away, because we'll have x plus 2 times 4, or 4x plus 8. Collecting like terms on the left-hand side gives me 5x, and subtracting 4x from both sides gets rid of the 4x on the right-hand side. So you're going to subtract 4x from both sides. That simply leaves me with the 8 on the right-hand side. 5x minus 4x is just x. So without any further steps, without any division, we have our final answer of x is equal to 8. Okay, let's try a couple examples where we have rational equations. Just means we have a lot going on in the denominator, but finding the LCD, multiplying all terms by the LCD, and then solving the simplified equation, all those steps are exactly the same. All right, you know what my first question is going to be. What's the lowest common denominator? Here it might help us to look at prime factors again. Prime factors of the first denominator are 2 and 2x minus 3. For the second one, they're 2 and 2. It's okay if you think of this as 4 and you understand that that's 2 and 2. I'm just writing it out very carefully. And 2x minus 3 is prime. So its only factor is 2x minus 3. Again, the LCD has to have all of these elements and therefore needs a 2 and a 2x minus 3. So we have 2, I'll write 2x minus 3 in brackets. In order to be divisible by 4, it needs 2 2's at the same time, so I better multiply by a second 2. Looking at the third denominator, the one on the right-hand side of the equation, I need a 2x minus 3, and I've already got one. So the lowest common denominator is 4 times 2x minus 3. The next step is to multiply the entire equation by that LCD. So I'll take the entire equation and multiply it by 4 and 2x minus 3. We'll take a lot of space to write this out, so we can clearly see what's being canceled. So here's each term in brackets. Then I'll show it multiplied by the LCD. And we'll cancel each carefully. You don't have to write this line. For some problems, I admit that it's quite straightforward to do it in your head, but it's sometimes nice to make sure that all our plus signs or minus signs, places where we need to use distributive property, are clear to us. All right, now we go through and cancel. 4 divided by 2 is 2, and 2x minus 3 divided by 2x minus 3 is 1. So we have 2 times 3 remaining from the first term, or 6. The second term on this left-hand side, we can cancel the 4's. So we're left with 2x minus 3 times 1. Because of the plus sign, I don't need to put the 2x minus 3 in brackets, but certainly if this was a negative, I'd have to be very careful to ensure that I'm applying the distributive property here, or simply leaving the 2x minus 3 in brackets for now. And on the right-hand side, we can cancel the 2x minus 3's, and we're left with 5 times 4. 5 times 4 is 20. So we'll always have this one messy line, and then we take it right back to a much more simple problem. I only have a single instance with an x, a single term with an x, so I'll leave that on the left-hand side. 6 minus 3 is 3, so I'll subtract 3 from both sides, and 20 minus 3 is 17. Finally, dividing both sides by 2 isolates x on the left-hand side, and we'll leave the answer as 17 over 2. Let's try another one. The trickiest part, again, is just finding the LCD, and once we're there, we'll follow the steps in exactly the same way. What does the LCD have to be here? Well, I need it to be divisible by x plus 3, and x plus 3 is prime. Remember that x and 3 can't possibly be factors of x plus 3, because if you tell me the factors are x and 3, I'm going to assume that the term they came from is 3x. In other words, I'm going to multiply the factors together. So if that doesn't give me x plus 3, it seems that x plus 3 must be prime. From the next denominator, I see that I have a 4 and an x. So I need both of those in my LCD. I'll need to multiply it by 4 and also by x. X and x plus 3 aren't the same thing. Finally, looking at this third denominator, I realize I already have an x plus 3 and an x, so it doesn't add anything to the LCD. So to tidy that up, the lowest common denominator is 4 times x plus 3. I'll take the entire equation and multiply by the LCD. Start. And here we go. 3 over x plus 3, the first term, and it's multiplied by 4x, x plus 3. Take 4x, x plus 3, and make sure I also multiply that by the second term. And lastly, by the third term. I don't mind that I'm running out of space because I have a 0 on the right-hand side. So even though, of course, that right-hand side is also being multiplied by the lowest common denominator, by 4x times x plus 3, 0 times anything is 0. So I'm going to leave that as 0. All right, we can go through and cancel. The x plus 3's cancel from the first term. The 4's and the x's cancel from the second term. And the x's and the x plus 3's from the last term. And we've already done the multiplication on the right-hand side. if you find you're in a situation, we don't see this here, but if it happens that you still have a denominator left over, it just means that you didn't find the lowest common denominator. Your number was too small. So simply multiply by whatever your leftover denominator is. What do we have left here? So we have 4 times x times 3, or 12x. From the second term, we have negative x plus 3 times 1. So we have to be careful to write that x plus 3 in brackets because we are subtracting everything that comes afterwards. We won't make those look like absolute value bars. Here we have negative 4 times 5, so negative 20. And that's all equal to 0. Now we just need to tidy up using distributive property and then collect like terms. So we have 12x minus 3 minus 20 is equal to 0. 12x minus x is 11x, and negative 3 minus 20 is negative 23, but then I'll add 23 to both sides to move it over to the right. Dividing both sides by 11 gives me 23 over 11, and we're done. This one looks like it's got a little bit more going on, and that's just because we have multiple brackets in this first denominator. You know what the first question is? What is the LCD? Well, it's got to have a 2x minus 1 and an x plus 4. Those are the two factors of the first denominator. Looking at the second denominator, I see that I need a 2 all by itself, but I've already got a 2x minus 1 in the LCD, so that won't add anything in addition. And, well, I've got a 2 and an x plus 4, a 2 and an x plus 4 in the third term, so we're good to go. So to tidy that up a little bit, I would write this as 2 times 2x minus 1 times x plus 4. And now, of course, we'll multiply both sides by 2, by 2x minus 1, and by x plus 4. So now we'll multiply each term, So now we'll multiply each term by 2, 2x minus 1, and x plus 4. And once again, because the right-hand side is equal to 0, I'm not going to multiply it by 0. I'll just have equals 0 on the right-hand side. Skip ahead to the answer, in other words. All right, there's lots I can cancel here. 2x minus 1s, the x plus 4s, and I'm left with 2 times 2. I'm left with 4. In the second term, the 2's cancel, the 2x minus 1's cancel, and we're once again left with negative, so be careful here, x plus 4 times 1, so we don't need to write that. And then finally, the 2's cancel, as do the x plus 4's, and we're left with positive 2x minus 1 times 3. Again, if you use distributive property immediately, that works as well. So let's tidy that up. That's 4 minus x minus 4 plus 3 times 2x is 6x, and 3 times negative 1 is negative 3, and that's all equal to 0. The like terms are negative x and 6x, so we have 5x that I'll leave on the left-hand side, 4 minus 4 is 0, so we just have negative 3 on the left, but I'll move that over to the right by adding 3 to both sides. Finally, division of both sides by 5 gives me x is equal to 3 over 5. Now we've done another one. Last question. I'll show you two different ways to complete this question. You may already have an inkling what those are. First, we'll tackle it in exactly the same way we just looked at the last couple questions. What's the LCD? Well, it's got to be 2x and x plus 2. In this case, it really is just the two denominators multiplied together. So you will see that occasionally. And certainly if you multiply all of your denominators together, you will get a common denominator, just not the lowest one. And if we have the lowest common denominator, that's what makes the next lines so easy to simplify. All right, what would we normally do? Well, we would take both sides, the 5 and the x plus 2 and the 3 over 2x, and we'll multiply those by the LCD. So by 2x, by x plus 2, on the left by 2x, and by x plus 2. All right, let's simplify. On the left, the x plus 2's cancel, and on the right, the 2's and the x's will cancel. So on the left-hand side, we're left with 2x times 5, so 10x. And on the right-hand side, by 3 times x plus 2, so by 3 times x plus 2. I'm going to pause there and show you a different method. Because we have a single term on the left and a single term on the right, and an equal sign between them, this is a good candidate for cross multiplication. The only reason I don't like bringing up cross multiplication is that we can't apply it everywhere. So be careful of that. You can only apply it when you have one term on the left, one term on the right with an equal sign between them. Here's how it works. You'll take the numerator of one side and multiply it by the denominator of the other. So in this case, we'll take 5 and multiply it by 2x. Then we'll take the denominator of that side and multiply it by the numerator of the other side. And that x that I've drawn is the x from cross multiplication. So on the right-hand side, we have x plus 2 times 3. So hopefully what you notice is that those two answers are so far identical. So the reason that cross multiplication works is because what you're really doing is you're multiplying both sides by the lowest common denominator. It's just skipping ahead by a step. So again, we couldn't do this before because it only works when there's a single term on the left and a single term on the right. But because these two are identical, I can solve either of them. So I'll continue working on the right-hand side. 5 times 2x is 10x, and x plus 2 times 3 is 3x plus 6. I move the 3x to the left-hand side by subtracting 3x from both sides. And finally, division by 7 gives me x is equal to 7 over 6.